Guys, welcome to Ray Engineering Techniques. So here is a question on moment of force. So the question says a 300 Newton force P is applied at point A of the bell crank. Shown for question A, it says compute the moment of the force P about O by resolving it into horizontal and vertical component. Don't forget this is our force P. Let me use a thin line. This is our force P. This particular force P is acting along the is acting slantly, as you can see, it's acting slantly. So that means this particular force P will be having both x and y components of force like this is what I mean, the x and y component of this particular force. That means this particular force will be having both. And we know from the definition of our moment is defined as the product of force and its perpendicular distance. Then, so now let's come back to this. Let's analyze this. Since we are having a force P in this direction, as you can see, the first thing that we are meant to do is, so we have to look for the component of this particular force that is perpendicular to this distance. You get? So how do we go about it? So let's start. So that means first thing we have to do is, let's extend this particular line OA outside. So that means we'll be having, this particular line OA be extended out, which is like this red line. So that means it will be having both your x and y. As you can see, this will be your px. This particular one that I use green line will be your px, and don't forget this one is parallel to this particular line OA, and this will be your, so let me use another dot, this will be your perpendicular. As you can see, the force here is perpendicular to this particular one. So that means the moment, if you are taking moment about with respect to this particular force, you will have a value. But if you are taking moment with respect to this parallel one, it will be 0, because from the definition of moment, we know it is the product of force and perpendicular distance. And if both of them are parallel, the moment about that point is 0. So now let's resolve this particular thing, since we've already analyzed it in that aspect. So from here, that means now let's create another line that will be parallel. Let's extend this, that will be parallel to this particular line here. Let's create another line, as you can see. So that means if here is 40, the angle here will be what? 40. Alternate angles are equal. And if here is 40, the angle here also will be what? 40. Now, how do we now go about this? Since this will be, let me use another line. So this will be our y component. So that means the total sum of angle in this direction is 90 degrees. So let's call this A. Let's call this A. Let's call the angle here A. The angle here A. So that means if we want to look for A, so that means 90 degrees will be equals to 30 degrees plus A degree plus 40 degrees. So that means our A degree will be equals to what? Our angle A will be equals to, our angle A will be equals to 20 degrees. So that means this particular angle AM is equals to 20 degrees. So we can actually now bring this particular diagram out. So that means we'll be having this place will be 20 degrees. This will be happening in this manner. Okay, let's extend this like this. And this will be acting in this direction. Don't forget, this will be your P perpendicular, this will be your P parallel. So we now taking moment, we know is the product of force and perpendicular distance. So that means your moment about this point will be equals to the product of force. Now, how do we now go? We have to resolve this particular force into x and y components. From here, product of force, which is P in this particular aspect, and perpendicular distance. So resolving this, our P perpendicular. So that means we know our P from here. That means we have sine theta to be equals to our P perpendicular. This will be our P. Our P. So that means our P here will be equals to our P perpendicular, which is our P perpendicular. We are looking for P perpendicular will be our P sine theta. So that means our P perpendicular will be equals to 300 dot times sine 20 degree. So that means our P perpendicular will be 300 times sine 20 degree, which is equals to 102.6 Newton. But the question is asking us using the compute the moment of force P about to by resolving it into horizontal and vertical component. So you can look for this P parallel. So that means our P parallel, let's look for our P parallel also. Our P parallel will just be equals to P cos theta. That means we've already resolved it into vertical and horizontal component. That means our P parallel will be equals to 300 times cos 20 degree. So that means P parallel will be equals to 300 times cos 20, which is equals to 281.9 Newton. Now, you now know our moment is the product of force and perpendicular distance. So that means our moment will be this force that is perpendicular to this particular distance, which is your 102.6 Newton times. Now this is our distance. These are our distance from O to A, which is 200 millimeter, and we know 1000 millimeter is equivalent to 1 meter. So we can actually convert this to meter, which will be equals to 0.2. So that means our moment about this point will be 102.6 times 0.2, which is 20.52 Newton meter. Now, I know most of you might be wondering that how did I resolve this? Now, from here, as you can see, this will be like, okay, let me erase that. Don't forget that, like, this will be more like your P parallel. So that means this will be more like a your P perpendicular. So that means if you want to take moment, you take moment in this direction. Taking moment in this direction, as you can see, your P, the direction of this your force with respect to the direction of this your force P, you take moment in this direction. If it is going in the opposite direction, you take moment in the opposite direction. As you can see, taking moment in this direction indicates we are taking our moment in the counterclockwise direction. Counterclockwise direction, which is also known as CW, denoted with denote it as this. This is W. So that means if you are taking your moment in the counterclockwise direction, you are going to have positive. But if you are taking it in the clockwise direction, that means the value for your moment will be what? Negative. So this is all for part A. Now to part B. The part B now says, using the result of part A, determine the perpendicular distance from O to the line of action of P. To the line of action of P. So that means part B, we know our moment for part B to be equals to product of force and perpendicular distance. So using this particular, since the question says using the result of part A, so that means we are using moment of part A to calculate the perpendicular distance of this. So that means the perpendicular distance of P to the line of action of P will be our moment over the force. don't forget the initial force given was 300 Newton. So you are using this particular 300 Newton to get how this particular force will be perpendicular to this particular line OA, to get the distance in which this particular thing will be perpendicular to it. So that means, you know, our movement to be equal, sorry, our perpendicular distance, that means our distance will be equal to 20.52 over 300. So that means you'll be having 20.52 divided by 300, which should be equals to your D will be equals to 0.0684 meter. So we convert this back to millimeter, that's times 1000. So that means your D is the same thing as 68.4 meter. So that means millimeter, yeah. So that means this will be in this particular, your 68.4 will just be the one that will be perpendicular to this force, will be in this particular direction. As you can see, it will be in this direction. So thank you very much. Here comes to the end of the class. Make sure you subscribe to my YouTube channel and always turn on the notification button.